Hello, everyone. I'm Ingy, Youssef, and I wanted to share with you today some protocols, standards, and schemes that will be absolutely awesome and important for this very special year, 2020. Think of this as the harvest pick for identity access management for the year. So before we get started, when we say identity access management, that's huge. So that's not only authentication or authorization or identity lifecycle. That's like a huge, huge space with tons of stuff. But you know what? The most important thing that is common across all this is that there are two things that we really care about. And usually we really need to work really hard to balance them. These are the customer experience and security risks and threats. And you know what? The idea here is that this is no longer, balancing this is no longer a luxury. And I'll tell you why. Nowadays, I want to draw your attention to these four main blocks. And the reason why I bring up those is that it is a two-way street for both, for those and identity access management. You know why? Because identity access management have a direct effect. The maturity of identity access management programs in enterprises have direct effect on them, on each of those. And also these things have challenges of a very a special type for identity access management programs across enterprises. So let's just get those awesome stuff, get around about for these awesome stuff and learn more about them. But the first one is really digital transformation. So when we're talking about identity access management and digital transformation, enterprises wanting to meet teams where they are, enterprises wanting to open up their business and provide their services accessible in different platforms, access through APIs and their data as well. All these things, these are the root and the heart of digital transformation. And with all this comes very important considerations of how the identity access management experience should be in order to enable those kinds of very different services than what we used to do before in our enterprises, closing down on data, closing down on services. Now we're opening up. Now, so if the identity access management services here are heavyweight, it's friction, has lots of friction with them and stuff, it's not going to help. And vice versa, digital transformation across all the different enterprises going through it now have a very special type of challenges that it introduces for identity access management. It's a different model. You literally have to look and think of things differently and go more fine-grained, and so on and so forth. Now, moving on to the next one, and that is the cloud. So right now, we're really anticipating that most of the organizations will have their data in the cloud, like really, really soon. Like, I mean, lots of data we're talking about, like 100% like, you know, next year or something. So we're really talking about operating fully in the cloud. And the thing here is that in order for cloud journeys to be successful, it needs to have really an identity access management program that's based on automation, that is capable and that is modern and that is cloud friendly. Right, and so with that comes that's the success of this journey. Can't be without this, and also vice versa. Cloud is by itself has lots of puts a great emphasis on IAM. Identity access management is the new parameter for the enterprises because of the cloud, where everything is, the new parameter is the identities and the access management and the access rules that are governing the access for those identities. It's no longer networks and physical networks, right? There's no inside or outside. Now, moving on, DevOps. So DevOps, this awesome vehicle to deliver code and software at speed. And with speed, that means you can't be a heavy manual IAM processes in the path to and stay, you can still do DevOps. So identity access management and automation and being able to have those operations really efficient and covered, all these things are very important for success of DevOps in organizations, and vice versa. Concepts of least privilege, change management, all these things are real things that IAM programs needs to understand how it can be tackled for DevOps. And finally, zero trust. And I think like it's a cliche. Really, everyone wants to see what is DevOps, what is zero trust, what does that mean for us, what does it bring? As this is coming and it's in the future, or sometimes some enterprises have managed to go on this journey, you cannot buy zero trust. It's built on really lots of practices and things you keep building across the years, from data classification, segmentation, and very, very strong IAM. And granular permissions, and also privileged access management. So again, you can't do zero trust and succeed with it without a strong IAM program, and vice versa. IAM does have lots of challenges when it comes to an emphasis when it comes to making zero trust a reality. And so with all these beautiful stuff, the journey for anything identity access management, as big as the space is, it's centered around a very small concept, which is the concept of digital identity. And for this concept, if you look at how this concept is evolving, you will clearly see what you really need as an enterprise to focus on. And so we started early on with the traditional scheme, where we're talking about really that in order for the user to interact with different applications, they need to really create a different account with each of these applications, as if they're really interacting with each, there's a different issuer for each of those applications to interact with. That was some time, and then comes federation. We're talking here about, you know, SAML-based federations, RBAC-based authorization models, and all these things, where really what was happening here was we say, hey, let the experience improve here. Why do it's the same user, right? Why do I need to create multiple identities? Can I just have an identity that's managed by a certain issuer, and then those apps can just use this issuer or this trusted identity management system to authenticate the user, and then we can, you know, go from there. So it's more like it is still more organizationally controlled. There's some big brother something here that's working on, which is this issuer, the trusted identity provider, you know, but all this, that's in the federated model. Now, let's go on to the current model, where lots of enterprises that are going through their digital transformation journeys are actually passing through it, which is the user-centric identity. In the user-centric identity, the user is at the center of the experience. We have what we call digital customer journeys mapping, and we have people study how they can improve on this and but also with that comes lots of things that we can do for IAM that makes this a success. And here it becomes the flexibility of, hey, I don't need to use this specific identity provider or issuer of identity. I can choose who I want to use. I can, for example, authenticate with Google or Facebook, or this IDP for my enterprise, or the second one, or the other one. It can even be registered dynamically. So that brings us to this user is at the center of the experience, and we design based on that. And then moving forward to self-sovereign identities. And with that, we're really talking about how can the user is the owner of the identity, and how the user can control what to share about their identities and with what data. So no control over the user's identity, or issuing or basically, the user does not need someone to issue an identity on its behalf. And we will learn more about that and it's how can this become a reality through blockchains. So most of our enterprises, if you're going through a digital transformation, probably you're having lots of conversation around how you can personalize the journey, the experience for the users. And probably you need to ramp your IAM program to be more user-centric, with user-centric identity protocols and services. So from that, let's take a look a little bit here on one important thing, just to make sure that we really set the ground right. We are going to explore a number of protocols and things, And some of them I will use the word, hey, that's older than this. That's the newer approach. That's. Think of all these as tools in your toolbox. So we're not doing an in with the new, out with the old. No, 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 no. Keep it in. There's no one leaving here. The idea is that the organizations will have this great toolbox to use based on the context, based on the problem being solved, and we need to make an informed decision of what works best for us. So just to reiterate again, the IAM is a huge space, and we're going to focus more on authentication and authorization primitives throughout this talk. This is, as you can see here, this is the FICAM architecture model. It's a federal identity credential access management model. I like that they have lots of resources there, but just I took this for you here and I highlighted those, and this is going to be our focus. Now, since this is going to be our focus, let's just make sure that we are on the same page when it comes to some terminology. When we're talking about authentication, authentication is really about making sure that the user is really who he or she is claiming to be. So there's some identity claim that's being verified by some verifier. Now, the claimant, who is the person to be authenticated, have some factors that is being used during this authentication process. The factors is something you have. So for example, you have a card, you have something you know, like your password, something you are, like your fingerprint. If I combine more than one factor, we call it multi-factor. It can be 2 factors, 3 factors, but these are this is how the claimant can prove to the verifier through the use of this factor through a certain scheme, which we call an authentication scheme, that it is indeed who it is claiming to be. Now, authorization is answering a different problem. Authorization is saying, is the subject allowed to access the requested object with the indicated operation? And so in that case here, the subject might have some attributes, group belongings, roles, and and similarly for the object. And there is usually a place where this decision needs to be done. It's this enforcement of access needs to be done, which we call usually an enforcement point. And it can consult with different things or do operations itself in order to reach the answer to this question. Just so that we make sure we follow through, we're going to start first by authentication, then switch to authorization, and finalize after that with our talk with some new trends and stuff. So starting with authentication, first of all, before we can start going into any of the schemes or the things you want to talk about, I really wanted to share with you this framework. So what is this? As you can see here, this is a table of some criteria, okay? We're going to use this throughout this talk to compare the different schemes and things that we introduce and talk about. Now, this is not something that I came up with. This is actually something that was based on a research in a paper published in 2012. It's an older paper, but then it's been revisited a number of times, and Google has used a number of references, a number of paper. Why am I bringing this here? Lots of times, again, from experience, you find that the enterprises are in situations where we're making some decisions. It's just based on, oh, this is set to be the standard, the industry standard. Oh, great, industry standards are awesome, I'm all in for it. But is it the right thing to do for your situation? Is it the right thing to do for this feature, for this project, for this effort? This is where this framework can help you. And so I brought it in here, and I'm going to show you how this will help indicate or how we can use it to compare the different frameworks. But then, as you can see, it is made up of 3 main categories. Usability, which tries to measure the user experience here, and deployability. As an enterprise, is your life going to be hell after you adopt the scheme? And then security and privacy, which is security considerations and privacy considerations. And I'm going to give you an example. So usability. So we're going to take a look and say, hey, is the scheme involve something, how is it from a memory-wise effort? Does it involve, is it easy to learn? What about, is it efficient to use? Does it, what about infrequent errors? That measures the user experience. Now, from a deployability perspective, look, cost, the cost per user. What about compatibility? Is compatible with browsers, different types, not all. Maturity, that makes a difference. We're supporting other security and privacy. For the third category, let's take a look at this. Is it resilient to phishing? Is it resilient to theft? Does it include consent? Is the user ever asked, are you okay with sharing your identity data? So all these things are very, very important. And I'm going to show you how we're going to apply this. So the flow here is as follows. I want to introduce you to some of the protocols and the frameworks and the schemes and models that are going to help you as we're going to address those newer challenges, like for digital transformations or DevOps or cloud or zero trust and or. So in order to do that, so what I'm going to do is really I'm going to work with you on first password-based scheme and then passwordless. And then during that time, I'm going to pivot to federation and show you how these two different models work when we're talking about federation as a concept here. So we're all familiar with password-based authentication. We see it all the time. You enter username and password, and you log in. You create some account with the application, and then you use the credentials to log in later. So there is some secret that is shared with a server somewhere that authenticates you when it's time to be to authenticate with the password-based authentication scheme. Now, I'm going to pivot to passwords via single sign-on or federation, basically, federated access. And the reason I want to pivot so fast here is really it is a real need for a fast pivot. So first of all, instead, it is as simple as this. The user wants to use a certain application, application A, and wants to use application B, and wants to use application C. Question, do I need to create an account with application A, application B, application C, application D? Okay. But is there an easier way? Is there a better way? So that's federation. Federation says, hey, you can use, if there is some identity provider or identity management system or verifier that you trust, and as an application, you can actually use this to log in your users. So for example, I'll give you an example here, which is a single sign-on for consumer apps. So this application here, say for an application called Travelopedia, whatever that is, and it has this sign-in with Google. So it doesn't tell you have to create an account, but it allows you actually, if you have a Google account, you can sign in with Google. We call this social login, but that's also a form of federation, because Google in this case, as an identity provider, acts as an identity provider and allows you to authenticate with your Google credentials, with your trust relationship with Google across all these apps without having to have Travelopedia collect your credentials and store it at all. Now, on another note, probably lots of times, probably you've seen that, absolutely. In your company, you log into your computer and you have, here you go, single sign-on, and at this pass, you're able to access all the suite of applications for internal use only. This is the board for this, and this is the area for that, and so on and so forth inside your enterprise. That's single sign-on. You sign in once and you're signed in already to these applications with this single sign-on. So that is great. We are going to explore the protocols for single sign-on and look at more towards the details of the newer one, which is the first one I want to draw your attention to, which is what we call OpenIDConnect. But before that, I really want to show you how I've used the framework here. And it's not me. That's I included the link here where references the paper and also the blog, the article that was wrote on that. But basically what we're talking about here is comparison of password versus password via SSL, so password-based authentication versus if you're using federation. Here are the categories, and if I'm gonna look at this, so you clearly can see how federation is helping with usability, absolutely. Now deployability, some problems here a little bit because of costs and things. Now, also security and privacy is enhanced. But look here. So resilient to phishing. I want you to hang on to this idea because we're going to explore it even more coming in. But I want you to see that none of the password-based scams are able to protect against phishing. Hold on to this idea. Okay, perfect. Now, OpenIDConnect, which is, this is an identity layer that's built on top of a protocol called OAuth. And OAuth, it's not a protocol actually, it's a delegation authorization framework because it's not a protocol. But OpenIDConnect adds an identity layer, and this is actually also can be used for federation. So there is the federation protocols that are most common are SAML based federation, and there's OpenIDConnect based federation, and there's other stuff. We know that there are other stuff we're not going to talk about now, but I just want to highlight under the spotlight OpenIDConnect for federation, and specifically for consumer apps. So let me take you since, and by the way, I modified this. So I took this diagram of OpenID, this logo of OpenIDConnect, and I placed center in it the OAuth logo, because it is really a part of it. I can't talk about OpenIDConnect without mentioning OAuth. So you might say, Ingy, you're talking about authentication. For God's sake, what does authorization have to do here with authentication for federation? What is that? So it's very simple. So you were during the remember in the older protocols, the older approaches, it's more about, hey, there's this user who wants to authenticate, and so we authenticate them with the SAML protocol, with the identity provider of choice, and then a certain assertion detailing the identity of the user is returned back to the requesting application, right? That's the normal federation flow. The problem here is that, again, zero consideration of the user itself, whether the users are okay with sharing their identity attributes with this application or not. Nothing of this is considered. OpenIDConnect brings us back to the user, what we call the user-centric experience, okay, for identity access management, and here for authentication. And so what happens here is that it's really critical to authorize the application that the user wants to use, Travelopedia, to make sure that the user is okay, obtain the user's consent before sharing the user's identity with Travelopedia, the application or the client. And so that is where the OAuth protocol comes in. And so what's happening here is, it's really, this is a very high level diagram, okay? So what's happening here is that the application, Travelopedia, the client, we call it the client as well, and we call it RP, relying party, we call it resource provider, like, oh my gosh, like tons of things, terminologies here. But the user is gonna be using the application, and the application will be like, oh, come on, hey, you know what, I need to get this user to authenticate with their with the identity provider, with the identity provider. Say if it's a social login, it's going to be Google. If it's something belong to a certain company, it's going to be that company, and so on and so forth. So there is those steps here, 1 and 2. It's about obtaining an authorization grant. It's getting a proof from the user that says that they are okay with sharing their identity attributes with this application, Travelopedia. Okay, so now this application is gonna take this authorization grant and go to something called authorization server. Give it the grant and say, here's that's the proof. This shows that the user is okay. And so the authorization gives back some stuff, and the identity, we're gonna see the identity, but then it gives back an access token. Now the access token, the application, Travelopedia, now have the access token. Now we can use the access token to get more details about the user if needed. This is because the user have said it's okay. See, the user-centric experience. It's very respectful of the user and their privacy and their needs as well. Now, I want you to hold on to this idea. Now, let's go into this diagram. I know it's big. We're not going to go into over all the flows, but I really loved it. I just thought it's going to be very useful for you to see that. And what I would definitely say here is that you do have those browsers, and this is what we call in the authentication, the federation word, what we call the identity provider. And assume that you have an identity provider that supports both SAML and YDC. And I want to show you just how both differ. It's a mindset shift. Because if you look here at what happens in the SAML flow, so if I assume that this part here is not there, and just look at the green, okay? So in this part here, a user is trying to use Travelopedia, which is say at sp.example.com, okay? And so the user will say, hey, I want to access that. I want to log in or do this. And so the Travelopedia redirects the user to the identity provider. And there, the identity provider is gonna display a login screen for the user and tell them log in. And the user's gonna log in stuff, and then there will be some signed SAML response received. The SAML is an assertion, and it is signed and include a number of claims yeah, I'm used more to the OpenIDConnect, I prefer to use that. But anyway, so the claims or basically assertions around the privileges the user has in the groups and the stuff, information about the user in the SAML, and it's returned back to the client here, and the client is just gonna validate the signature and stuff and say, good. Yeah, that is indeed the user. We've just did that. Now you can access the resource. Now let's look at the same flow here, but let's see if I'm using OpenIDConnect. And I want you to see the respect, how the user is being respected here. And the user is the owner. Look at it. The user is the owner of its identity, his or her identity. And the user is the king or the queen of their identity. It's really that way, but we've for so long dismissed that. But now OpenIDConnect again, the user-centric experience. So look at this. So there is a request for the user wants to access request and say, hey, I want to access this, I want to log in and stuff. The users, then there is some OpenIDConnect authorization code request that is sent to the IDC, and the user is redirected to log in with the identity provider. Then the user starts interacting with the login page and enters credentials and stuff, but look at step number 6, obtain end user consent and say, here are your attributes. We're gonna share this. Are you okay? Are you fine with this? And then the user says a yes or no, and based on that, we provide the consent, and then it's redirected back with the authorization code. This is one of the flows, by the way. It's not all the flows. There are other flows for OpenIDConnect. I'm just gonna focus on the auth code grant for now. Redirect with auth code, and then with the auth code here, that's the proof that the user is okay. And now the auth code, now the client has it, and so based on that, the user is the client is gonna send a request back to the identity provider and saying, hey, I have the proof. Now please give me back the identity token, which is detailing the identity of the user and some claims, and it's signed. It's a signed JSON, which is the JOT, and return it back to me and give me an access token if I need more. And so that what happens, and then now the client has this identity token, validates it, and then they can ask even for more using the access token. Isn't it beautiful, right? It's beautiful. Okay, so OpenIDConnect versus SAML. So I just put this here for you to from different sources, but basically I just want to highlight a couple things here, and this is for your reference. But just a couple of things. First of all, interoperability. So SAML as a protocol, this does not support native apps, does not support mobile, machine to machine. No. Know that for all these, you need to use OpenIDConnect for federation. SAML is not going to work for you. Okay. Now it's only browser based. Now collects consent. We said SAML, no. OpenID, yeah. And lightweight, of course, OpenIDConnect is definitely using lightweight JSON. SAML is using XML. And one thing I just want to recommend is that if you are developing for enterprise apps and stuff, and they are already, you know, you have SAML ability to interact with to support SAML federation, that's okay. Now, when you're building new apps, put in your mind, again, weigh your benefits, weigh why, and where you want to take it next. And my recommendation is things are going towards OpenIDConnect. If you're building new apps for consumers, go for OpenIDConnect federation. And definitely, again, if you are protecting API resources, you'd better do it using OpenIDConnect anyways. It's built on OAuth, so why the plugging things with SAML just gets some tricky stuff. Okay, so now we talked about passwords, right? And remember, we had this, we talked about federation. None of them actually solved the problem of phishing. Obviously, it's like failing us badly here. But we're gonna use multi-factor. So multi-factor brings up the game to a better level, a little bit better, okay? And there's many ways to incorporate another factor. So the very common one, which is what we call the OTP, and there's many different types. So it's a one-time password, and there's many different types. So it's called HMAC OTP or time-based OTP. And the differences here is for the HMAC OTP, there is a one-time password sent to you, say, in an SMS or voice, whatever the way. But this one-time password is going to stay at the same, to stay valid until another one is sent or it expires time. And then what happens is that you enter the password and the one-time password in order to authenticate. The TOTP though is time sensitive. It's like an authenticator. It's an app on your phone or authenticator app, and it's just basically valid for any single point in time. There's only one OTP that is valid. So it's a little bit of difference, but I just wanted to point that out. This is the most common, right? And SMSs and voice and stuff based on that. Another thing that's also very common is mobile push, where basically when you log in with a password, then there's a push notification sent back, and there's like when you're logging to Office 365 and you get this allow deny, and hey, you click allow, this will basically sign a certain assertion, return back, and that will say, yes, the user is okay here, and yes. Unfortunately, what we just discussed here is still prone to phishing. The user is going to be creating a bad site, malicious site, and can harvest these things as well. So, and then relay them to the identity provider. So the phishing is still a problem. And if you know that, oh my gosh, like tons of attacks still happening because of phishing. And yes, human is the weakest link, but it's the most beautiful link. And so we have to find a way to make it happen, right? And so comes FIDO2. And I just took here, this is like a screenshot of the FIDO2, super happy about what they've done, Alliance. And then obviously what we're talking about here is what we call a multi-factor authenticator. It is also said to be a passwordless, and we're going to say here why, but it's not because there is no passwords whatsoever. It's just because the password is not sent and shared with a server. The password never leaves the device. I'll call it private key, but anyways, okay. But there is some pins and things, yeah, anyways. But this allows you, based on the FIDO protocol and its beauty, it allows you actually to compose multiple authenticators. Again, the user in full control. I can actually have a beautiful experience where I can use a compound many authenticators. It can be a hardware token, it can be my mobile device, it can be a PIN, it can be my biometrics, everything, right? So let's dive into a little bit into this and understand more. So we finished the password, come into passwordless. So So the passwordless, I'm introducing FIDO2. And think of FIDO2, whenever you hear the word, it's really an umbrella of two main protocols that have been actually incorporated as APIs in the browsers and the devices. So FIDO2 is a combination of two. One is called WEBAUTHN, and the other one is called CTAP. And then what it is doing is trying to find a solution by which again, the client, which is running maybe on your a computer or on your phone, wants again to authenticate to some remote server website, right? and send the authentications to this remote server website. And another thing here that I want you to notice is WEBAUTHN is the protocol that handles how the communication goes between the client and the remote server. The CTAP is the one that handles what we call remote authenticators, like how do we manage these conversations and chatting that comes between the removable authenticator, like a phone. Your phone can be acting as an authenticator actually for your applications, or you can have a secret key like YubiKeys and things. But also for your client, for even on your device, the same device in which you're running the application or the client, you can have built-in authenticators like through fingerprints and others. So beautiful. So what we want to do here and do understand is really how this thing works. Why is it worth it? Why does it really solve the phishing problem? Why is it passwordless? Here's the thing. Cryptography. So here is that. Assume that I have Facebook. I want to log into my Facebook account. Okay, and here's the Facebook server here. Okay, so what happens here? I have this. This is the really normal screen, but that's not what FIDO looks like really. Usually there is when it is time for FIDO clients. Creating an account, there's two things, registration and then basically the use, okay? So the thing is that, assume that I have a certain security key. So I say in this example, I have the security key here, and maybe it's my phone, maybe it's something else, maybe it's a hardware key, just like you see here. But what happens here is very simple. When I want to log in, before that, I have to create an account. So the way an account is created is the user, the client itself wants to get credentials created by the security key that we own, that Alice owns, how does this happen? The client, which is the client of Facebook, that is FIDO, supporting FIDO, uses the browser's API for WEBAUTHN in order to ask, hey, I want credentials created for a private and public key, and give me back the public key. So private key is a secret, and this device, and also I forgot to say that also the origin of the call is returned. So you have here, no, I'm sorry, not the origin here. So basically what's happening here is the security key is going to generate a private and a public key and return back the public key. And the browser is going to pass this back to the client. The client is going to pass this back to the server. And the server is going to now say, yes, this is the public key I'm going to use to validate a signed, whatever signed messages I'm going to get from this thing. Now, when it's time to use, let's follow this diagram now. It's time to use now. So the first thing is when it is time to authenticate, the server sends a challenge. Challenge is some nonce of some sort or something. And then the client, again, through the API, the WEBAUTHN and the CTAP APIs, whatever there's some more details here. But then it sends the origin, so it's the facebook.com along with the challenge, and asks the key to encrypt this. See the beauty of it. The key is going to say, hey, user, are you okay with me doing this action? because I'm going to sign this and send it. Give me your consent, and the consent is going to be a fingerprint or a PIN or whatever. So the user does this, and then based on that, this device, the removable authenticator, is going to basically encrypt the, it's going to sign both the challenge and the origin and return it back. So it's signed. It's signed with the private key. Now, how the signature can be validated, the server does not need the private key at all, and it doesn't know anything about it. It needs only the public key. This is the asymmetric cryptography, right? So we go back, and then all the way the client sends that signed assertion about the challenge and the Facebook, the origin to the server. It validates it, and yes, that's it. Now, if I find something like maliciousfacebook.com with it, which is the phishing ideas, right? It will catch it. Now, there's many types of authenticators. Again, we have roaming authenticators, built-in authenticators, and the options, it's beautiful. Really, the options are a lot. You might think, okay, wait, hold on. How does this relate to single sign-on? So you've been talking about OpenIDConnect and your protocols and these things in SAML. What does this have to do with that? These were password-based, so does that mean this is replacing SSO? No, 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 no. This is actually complementing the SSO experience with this beautiful experience of FIDO. So think of all the SSO like flow, it's the same as you're used to, but then there is one only step that instead of signing in with your password, you're gonna sign in with the same steps of FIDO. That's it. Otherwise, everything is the same. And the results are in. And I'm reiterating, I put all these stuff here because I want you to see how these platforms, how these things compare. And what is important about this is that that's not what you're going to use. Don't use this comparison and say, just because it is supporting for, it is browser compatible, for example, server compatible, I want to use it, or no, I'm not going to use it. No, it's based on your application of it and your use and your needs. Don't go beyond that. It's not based on the standard. Like, this is great, but this will allow you how to, based on how you value each of these attributes and you're based on your use case, you're gonna make a choice. So now with stack authorization. So for authorization, again, is trying to see really, can a subject access the object at this time with these attributes, with these conditions, right? So access control models have been like since eternity. Lots of them have really matured over time. And from access control list, role-based, APAC, attribute-based, policy-based, which is, you know, for now, probably need to take it for now, attribute-based, and policy-based are usually used interchangeably. There's a little bit of difference. It's okay, just use it interchangeably for now. And what we call RADAC, risk adaptable access control. So in order to explain this to you in an easy way, I've been thinking about that. Disney, oh my gosh, when will the COVID be out of our lives? I don't know. But anyways, so the Disney rides, assume that there's a new ride, and all the beautiful access controls are gonna be used in order to authorize if someone should enter this ride. And assume it's new, so we need testers. Come on, you can't get just a customer riding a new ride without testing it first. And so my new ride is waiting for me, but the testers have to test. So the first one, the first protocol, which is the first model, it's not a protocol, the first model, which is access control lists, is gonna say, hey, is your name on the list? If that's the case, you go in, you're authorized. If that's not the case, you're out. RBAC, role-based access control, is all about roles and the permissions. And so if testers always have this green pass, because the role is defined by this green pass, so I'm gonna say, oh, you have a green pass? Oh, so you must be in the group of the testers, go in. Now, ABAC is gonna say, come on, what's your height? What's your age? What's the time of the day? Are we ready? Okay, go on, you're authorized or not. Your attributes. Based on the attributes of the subject, based on the attributes of the objects. There's some policies and rules defines should go or not. Redac is going to say, have you been to a COVID outbreak area lately? So it's really trying to put this more risk-based weighing in access control decisions. And there is a lot of it. And again, in order to support any of this, again, remember, it's your toolbox. It's not a bring in and throw the rest. Okay, please don't do that. There's tons of details here. Look at this, I just kept it. So you see the complexity of getting these things to be working and producing value for you. So we're gonna go now over what we call attribute-based access control. At the center of it, really, again, the subject, the object, and there's some attributes, and then some attributes for both, and there is some policies that governs that relationship. I wanna introduce you, be my guest, to the standard that is very widely known for implementing ABAC. It's called ZACML, and the latest version is 3. There's another one that is less known, like at least the vendors are supporting very strongly ZACML, but there's NJAC as well, next generation access control. But anyways, let's stay with the ZACML 3. This is how the architecture looks like. Usually there is some policy enforcement point where the authorization question comes from, right? So someone is asking me to view record 1, 2, 3. So the policy enforcement point sends to something that's called policy decision point. This is the one that really is responsible to provide me the answer should the policy enforcement point say yes or no. And it has lots of intelligence and logic there that allows it to do this. How? It accesses policies from what we call policy administration point, where all policies are managed, which is written in XML. And there is what we call policy information point, which retrieves the values of the attributes. Lots of decisioning happens here, and then the condition, then things are returned. ZACML has lots of features and things, and it continues to grow and improve. But most importantly here, we're talking also about ability to do caching and stuff. And this is, I tried here to get you also this comparison, and I've used lots of things, but the most important differences between ABAC and RBAC is that this concept of fine-grain access. ABAC can really go fine-grain and without, and still able to scale. So the problem is, yeah, you can go fine-grain with roles, but you're gonna have a role explosion, for God's sake. Now I can use, we call it multi-factored access also, not only roles, I can have other attributes. The cost of ABAC can be more higher because of the management of policies and things. Also, ABAC is more suitable when you need in a dynamic environment where it's not a static decision. It is based on what happens, I'm gonna apply another rule and then another rule, a third rule. So in dynamic environments, and there's other stuff for your reference as well here. Now, before we wrap up, I wanted to go over the road to self-sovereign identities using blockchains. So the pain points have been fraud, scale, flexibility, privacy, right? Consent, users not happy, and much more. And so users want to get control. Really, they want to get out of those organizations, out of those controlling entities, and own their identity and where their information is shared and how it's shared and what to share. And so comes blockchains. And if that's legal, I'm going to give you a primer on blockchains in 2 minutes. Yeah, 7 minutes. After 7 minutes? No. Okay. So here's blockchains in a very easy way. Assume that someone wants to have to do a certain transaction. Okay, so there's some transaction that needs to be done, and I want to see, can this transaction is this transaction valid, or I want this transaction to be completed, whatever my request is. But I have a team of a network of a peer-to-peer network of what we call nodes. These are going to be actually working together on my transaction, and each of them are going to be trying to validate the transaction or work on it. The first one to finish is going to be the winner. The winner is going to need to produce what's called the proof of work that's going to be validated by the network. Now, after consensus, everyone is happy, and now I can trust the decision of this thing. Now, what happens here is that this transaction turns into a block and placed in a chain. And this chain now has it permanent and cannot be altered and can be reviewed and checked and validated. So now let's use this concept and see how it will apply here. So, web of trust of the internet. Yes, it is time to decentralize this thing. So again, lots of stuff that we do across the internet and in our applications and in is dependent on public key cryptography. So I am as Ingy, I will come in and say, I have a private key I'm not going to tell you about, and I have a public key. And we can come together and we can create a secret. And I will create a secret with you in order to do other operations, but I'm not going to share with you my secret. Instead, we're going to use an algorithm called Diffie-Hellman's variance in order to be able to establish this common secret together. And so, but hey, come on, there can be someone else that comes in and claim that they are Ingy, and having a private and public key and give you a public key and say, hey, this is Ingy, create a secret with me. But that's not okay. It has to be that really there's a proof that Ingy is, this public key really belongs to Ingy, and Ingy is the one associated with this public key. This is where what we call certificate authorities comes. And usually there's a web of trust in which there's a certificate authorities, and there's a root certificate authorities and multiple other branchings based on that. And it's, there are challenges with this. And again, everything has to be registered with these certificate authorities and things. Remember, self-sovereign, getting away with all this. Here comes the magic of blockchains. And so in blockchains, really the idea here would be to say, sorry, the idea here is to say, can I really have a way, instead of asking the certificate authority to check my, to have the signed assertion, which is what we call the certs, right? Signed assertion that says, here's the public key and really belongs to this person, and signed by the trusted certificate authority. No, let's do something else. So blockchains, there will be a public ledger, this public network. And what's gonna happen here, it's a big, huge thing. And what's gonna happen is that the users need to register their unique identifier with their identity. And then whenever there's a transaction of any sort, what happens is that any user will take this claimed identity with the public key and provide it to the public blockchain for validation. And based on that, we can get more trust into that this is indeed the claimed identity related to this key, public key. And then the whole scheme falls through. So yeah, so that's just what I wanted really to cover for today. And I think we really went through password-based schemes and passwordless. We've looked at federation. We've looked at the new concept of empowered user through OpenIDConnect and SSO for consumer apps. We looked at passwordless and the beauty of the user experience and improved security and the challenges ahead on the road. Moving on to the more to come for blockchains and identity access management. And thank you so much for your time, and hope you the best. But I would just want to remind you, grow it now. It takes time. Start planting bringing all the tools in your toolbox, planting those roots for your digital transformation, your awesome DevOps, your wonderful zero trust journey. And definitely, I want to see you up there in the cloud. Thank you.